Hi, in this video I'm going to talk about smart pointers in C++. First of all, I'll talk about why we need smart pointers. Then I'll talk about shared pointers, which is the first type of smart pointers. Then I'll talk about the second type of smart pointers, which is unique pointers. Then I'll talk about the third type of smart pointers, which is weak pointer. And at the end, there will be a summary. Why we need smart pointers? This is the problem with raw pointers. So in this example, I'm calling this function. This is our example. And this is the function inside the main I call. And the function has for loop. Inside the loop, in each iteration, it creates a raw pointer and find it a dynamically allocated object in the memory of type integer. And then I assign this object a value. And here, if I forget to delete the pointer, there will be a memory leak. So after calling function inside the loop, the memory allocated to the pointer p using new is not free. Therefore, memory leak will happen. So smart pointer will fix this problem by replacing the raw pointer with smart pointer. In this case, it's shared pointer, and the shared pointer or the smart pointer will automatically free the memory, so that there is no need to call the delete operation or delete function for the pointer. So we can avoid the problem using smart pointer. When the object is destroyed, it frees the memory as well, so we don't need to delete it as a smart pointer will handle it. So using smart pointer, we will avoid any memory leak. The first type of smart pointers is shared pointer. Shared pointer is a smart pointer that contains shared ownership of an object through a pointer. Several shared pointers may own the same object. The object is destroyed and its memory deallocated when the last remaining shared pointer owning the object is destroyed. Example, this is an example for how to use the shared pointer. First of all, if you want to use shared pointer and the make shared method, which is used to create a shared pointer, you have to include this library called memory. This line is just to skip using std everywhere. This is how I declared a shared pointer. So I use this name shared pointer, and I have to provide it with the type. This pointer will point to an object of type integer in this case, and this is the name p1. Uh, and using new keyword, you can create object in the heap that's pointed by p1. So in this case, p1 is pointed to object with the value 4. In this line, this is another way to create an object pointed by shared pointer using method make shared instead of new. So make shared and give it the type integer, and this is the value of the object pointed by the pointer. So p2 now is pointing to an object with of type integer and value equal 5. Here is another way to create shared pointer using the auto keyword. I prefer this method. So you just use auto p3 equals make shared type integer and you assign the value 10. So now p3 is a pointer that points to an object of type integer and value 10. In this line, we assign p3 to p4 as we said here. Many shared pointer can share the ownership of the object. So in this line, p4 and p3 uh, are pointing to the same object, uh, which is which has the value 10, as you see in this diagram. So p3 and p4 points and on this object. That's why it's shared pointer. And here you can difference the pointer and print its value using the star operation. So P1 is 4, P2 is 5, P3 is 10, and P4 is 10 because P3 and P4 points to the same object. And as you can see in this example, we didn't use the method delete to release the memory. Because we are using shared pointer, the memory will be released automatically. Reference counter. What's the reference counter in the shared pointer? So by using shared pointer, more than one pointer can point to this one object at a time, and it will maintain a reference counter using useCount method. So let's say we have an object in the heap that's pointed by or shared by three shared pointers. In that case, each pointer will have use count or the reference count equal to 3. It's because three pointers point to the same object. Let's see an example. Uh, this is a class person that has two private members, name as string and age as integer. And this is constructor that takes name and age as parameter. And this is the destructor. And in the right side, this is the main function that used this class. The first line here is will create p1 shared pointer, and the type is person. So p1 will, and using the make shared, will create a new object that is pointed by p1. This object will take Sam as a name and 20 as an age. So now p1 is shared pointer that point to an object in the heap with the name Sam. This is why, and because now this object is pointed only by one pointer, so useCount method will return 1. This is here, return useCount equal 1. In this line, assigning p1 to p2, so a new pointer called p2 will point to the same object that p1 points to. So that object has two pointers, which are p1 and p2. And this is why if I print p1.useCount or p2.useCount, the number of pointer will be 2. Here inside this scope, I assigned a new pointer called p2, called p3. So p2, p3, p1 will point to the same object, and the use count will be equal to 3 in this line. And at the moment it exits the scope, p3 is no longer exist, and so only p1 and p2 remains pointing to that object. And if I call the use count here, it should return 2, as you see in this line. P2.reset, it will tell that P2 like don't point to this object, or release P2 from pointing to the current object, and so P2 will be like an empty or null pointer, and B1 will still point to that object. So we call B1.useCount, it's equal to 1, and B2.useCount, B2 is null pointer, so it doesn't point to anything because we use B2.reset. So P2 use count is equal to 0. Uh, P1 points to an object, and if I call P1.reset, it will tell like let P1 not point to the object, and so P1 will become a null pointer. But at this moment, when I call P1.reset, the object itself is no longer pointed by any of the shared pointer, and its use count is 0. So at this moment, because it's smart pointer, and the object that is pointed by P1 will be automatically released or freed from the memory, and its destructor will be called. And this is why you see destructor called, and P1 use count equals 0. So in this program, we didn't use any delete method to release the memory. It's automatically released. Shared pointer methods and operations. The first method is swap. If we have two pointers that points to two objects, two shared pointer that points to two different objects, using the method swap, it will make every object or every pointer points to the other pointer object. Get. So the shared pointer point to an object in the heap memory, but still inside it there is a row pointer, and you can get that row pointer using the method get. You can dereference the object or the pointer using the star operator or this operator to access the object pointed by the pointer. Reset method. There's two uses of it. The first, if you don't supply any parameter to this method, and you call like shared pointer dot reset, it will release this pointer. It will no longer point to the object, and it's become null pointer. Or you can supply a null pointer as a parameter, and it will have the same effect. The second thing, if you give it a new object, in that case it will make the pointers to point to this object supplied in the parameter. See an example. This is class person and has two members, name as string and age as integer. This is the constructor, this is the destructor, and this is public method called print name. And in the right side, we have the main function that use this class. Initially, I create pointer one, it's type shared pointer, and using the make shared function or method, it will make the pointer like points to a real object, name Sam and age 20. This is how I can do dereference the pointer using the star. So I can do star p1 dot print name, and it will print name Sam. Or I can use this easier operator, like the same way we use it's used in row pointer. So p1 print name will print Sam. In this line, I am assigning or creating a new pointer, point to a new object called Daniel. So now P1 points to Sam, and P2 point to Daniel, and calling this method swap, it will make it will swap the ownership. So P1 now points to Daniel, and P2 points to Sam. P1 dot reset. P1 points to an object that's only pointed by P1. So when I call reset, it means that P1 will no longer point to the object, and because the object is was only pointed by P1, its reference counter becomes 0 after this, so that the object itself will be released and the destructor called. So Sam or Daniel is released, and P1 is null pointer because I call P1 dot reset. P1 will no longer point to anything; it's empty pointer, and P1 will be released. P2 dot reset. I'm giving it a new object. As I said before, when you give it a new object, it will tell P2 to point to this new object, which is Tom, and the previous object, which was Sam, is destroyed because no longer any pointer points to it, and so the destructor is called for Sam. And if I print P2, the name of P2 is Tom, which is the new object here. F, this function here, is taking as a parameter row pointer type person, and I'll just call the name. And to do that, we can use P2, which is shared pointer, dot get. P2 dot get will return a row pointer so that we pass it to the function and can access the print name inside it. And after that, the program finished ended, and at the moment it exits or it returns or exits the scope, Tom P2 will no longer to point anything. This pointer is destructed, and so the object Tom is no longer pointed by any of shared pointer. It has 0 reference, and so the destructor will be called for Tom. Performance. Dereferencing a shared pointer has the same performance as row pointer. The memory that a shared pointer takes is more than a row pointer and a unique pointer. Unique pointer is the different type of smart pointer, since it stores extra information like reference counter. So it's slightly compared to the memory, shared pointer serve more memory than the row pointer. Creating, deleting, resetting a shared pointer involves some logic. Example, updating the reference counter, checking if it is the first or last pointer, and so on. Therefore, row pointers and unique pointer has slightly better performance than shared pointer. The second type of smart pointer is unique pointer. Definition. Unique pointer is a smart pointer that owns and manages another object through a pointer and disposes of that object when the unique pointer goes out of the scope. Unique pointers guarantees they delete their object if they are destructed. So unique pointer is similar to shared pointer. It's smart pointer. You don't have to call the delete method when you use unique pointer. The only difference between unique pointer and shared pointer is that unique pointer can only point to one object, and that object only can be pointed by only one pointer. Declaration. The same library I use for shared pointer is called memory. I have included to use unique pointer. and also make unique is a method to create a unique pointer. It exists in this library using namespace std. This is just to skip using std everywhere. This is the first way I create a unique pointer. Find unique pointer. The type of the memory that pointed by this pointer is integer. This is the name p1, and I'm using the new keyword here to create an object of type integer with the value equal to 1. So after this line, p1 is a unique pointer that points to an object in the memory with value 1. In this line, this is a second way to create unique pointer, unique pointer p2. There's no I avoided using the equal or assignment operation here, so directly you call new integer equal to, in this case p2, unique pointer that points to an object with the value equal to. This is another way, p3, using make unique method instead of the new. Make unique, you have to define the type of the value that is pointed by the unique pointer, which is integer. So in this case, I'm creating p3 pointer, unique pointer that points to an object with value equal to 3. And this is another way to use make unique. So in this line, I'm creating a unique pointer p4 that points to an integer with the value equal 4. I prefer this way using the auto keyword and make unique, so you don't have to put explicitly unique pointer with that integer. You just use auto, and the deduction is automatically happening. So auto p5 make unique integer 5. It will create a new pointer called p5 that points to an object in the memory with the value 5. In this line, I'm creating a new pointer, but I don't make it point to any object, so it's just empty pointer or null pointer. This is why here, if I check if p6 is null pointer, you see in the output p6 is null pointer. And again, unique pointer is a smart pointer, so there is no any need to call the delete method to release its object. Move ownership. Only one unique pointer owns the object on the heap. You can't copy or assign unique pointers to other unique pointers. Instead, use std-move to transfer ownership of objects to other unique pointers. So, unlike a shared pointer, you can use the assignment operation to make multiple pointers point to the same object. You can do this with the unique pointer because the pointer points to one object, and that object is pointed by only one unique pointer. But you can transfer the whole ownership to another unique pointer using std-move method. This is an example here. On this line, I create the pointer p1 that points to an integer with value equal 1. This commented line will give compilation error because you can't let two pointers point to the same object. Instead, you can use std-move to transfer the ownership of the object. So this means that transfer the ownership of the object pointed by p1 into p2. So p2 will point to that object, and after this use std-move P1 will no longer point to any object, and this is why if you check P1, if it's null pointer, a null pointer will be printed, and if you try to dereference the unique pointer P2, which points to that object, it will print P2 equal to 1. This is another example. Here we have function that takes a unique pointer as a parameter, so you can't say f of p2 because p2 will be copied to b, and this will give compilation error. Instead, you do std move of p2. This means that move the ownership from p2 to this parameter, which is p. And if you print it, so p is taking the new value, which is p1. So after you call std move, p2 itself is no longer point to anything, and if you check here, if p2 is null pointer, you will see it's empty and it's null pointer. Unique pointers, operations, and methods. This is the class we want to use for this example. It's class person. It has name as string and age as integer in its private private members. This is constructor, and this is the destructor, and this is the public method. Print the name. On the right side, we have the main function that uses this class. Here I create a unique pointer using make unique and the auto keyword. So P1 is a unique pointer that points to an object called Sam. And this is calling this method P1 using this operator like shared pointer and row pointers to access the public method, or to access P1 print name. It will print Sam. So P1 now points to Sam. P1.reset null pointer. It's like saying release P1 from pointing to the object, and so P1 is null pointer now. This is why in this line, after calling reset, P1 is null pointer. But at the moment I call the reset here, P1 will no longer point to the object, and the object is automatically released because it has no pointer point to it, and the destructor and the object itself is freed from the memory, so that you see the destructor code. In this line, I'm calling P1, which is null pointer, dot reset new person, Daniel. This means that make P1 points to a new object called Daniel, and trying to print its name, it will print Daniel here. So assign a new object to P1 using reset, name Daniel. Release. Using the release is telling the P1 that P1 no longer points to the object, like similar to what we saw in shared pointer. So P1 no longer points to Daniel object, and it's null pointer. But also the release should return a row pointer that points to that object, because internal unique pointer also has the row pointer that points to the object. So in this case, P1 dot release, it says make P1 null pointer, and P1 no longer points to the object Daniel, and return a row pointer. This row pointer, I assigned it here to row pointer, and trying to after P1 is null pointer is printed in this line, and here we're trying to access the print name using the row pointer we obtained in the above lines. The row pointer named Danny will be printed. But notice here we are no longer have smart pointer but point to Daniel instead of its row pointer, so you have to call the delete method explicitly to free the object because this is not smart pointer. Swap method. Here I'm letting P1 to point to a new object called Tom, and P2 is a unique pointer, new unique pointer points object called Adam. That's why P1 point to Tom and P2 point to Adam. After calling the swap method here, P1 dot swap P2, it means that let P1 point to P2 object and P2 points to P1 object. So P1 now point to Adam and P2 point to Tom. So after exiting the program, so P1 and P2 are released and their objects are no longer pointed by any pointers, because these are smart pointers. Their object will be automatically released and defreed, and this is why you see the structure called for Adam and the structure called for Tom. Unique pointer performance. Accessing unique pointers is as fast as row pointers. The class of the unique pointer contains only a row pointer as the data member, so the size of a unique pointer is the same as row pointer. Unique pointers can safely replace row pointer in high performance calculations. The first type of smart pointers in C++ is weak pointer. Definition. Weak pointer is a smart pointer that holds a non-owning weak reference to the object that is managed by shared pointer. It must be converted to shared pointer in order to access the reference object. A weak pointer does not take ownership of an object but acts as an observer. So weak pointer is similar to shared pointer, but it's not similar actually. It's just an observer to the object that's pointed by shared pointer. You can't access that object using the weak pointer. So why it's needed? The main reason weak pointers are invented is to break circular dependency of shared pointers. Let's take an example. Here in the right side you see class company. It has two private members. One is the name of the company and the CEO. The CEO is shared pointer of type person, and here we have constructor, destructor, and set CEO. So I can assign the company shared pointer of type person, which represents the CEO. And this is the class person. In the class person, it has two private members, the name of the person and shared pointer to the company. So this person belongs to which company? Here we have the constructor, destructor, and the public method set company, which takes shared pointer to company. Here in the left side, we have the main function that use those classes. First, I create a shared pointer called C type company. So now we have Microsoft as a shared pointer, and here we defined a shared pointer of type person called Tom, and I'm calling the public method set CEO for the company, and I'm passing it the shared pointer Tom. Then for the person, I'm assigning Tom to Microsoft company, so I pass the shared pointer C. And here just print program end. So what happens at the end of the program, it will say the company pointers point to Microsoft. So C is no longer exist, but the object Microsoft is pointed by some by shared pointer in Tom. So the reference count of the company uh, is one, and so the company shared pointer Microsoft will be pointed by another pointer inside Tom. So the reference count will be one, and so the object Microsoft will not be deleted from the memory, and the same for Tom. When it exits, it will say, is there any other pointer points to Tom? Uh, and the answer is yes, because Microsoft, it has Tom as private member, so the reference count will be one, and so none of the objects will be released. It's kind of each one depends on the other, and there will be circular dependency. This is why at the end of the program, you see program end without calling the destructor of any of the two objects. So weak pointer fixes circular dependency problem. Here we have the same example, but instead of having the company inside the person as a shared pointer, we have it as a weak pointer. The weak pointer is just an observer. It doesn't have reference count like the shared pointer, or it doesn't own the object. So at the moment the program exit, it will say, okay, the company Microsoft exiting. It does it has uh, any other shared pointer point to it, because the company inside Tom object is weak pointer, so there is no other shared pointer point to Microsoft, and it will call the destructor. And the same issue for Tom. When exit, Microsoft is already destroyed, so Tom will say, object, is there any other shared pointer point to Tom? The answer is no, so the destructor Tom is called. So summarize, like replace the shared pointer because there is circular dependency. You can replace it with weak pointers to fix this circular dependency. Access object. To access object observed by a weak pointer, you have to convert it to shared pointer using lock. So as I said, the weak pointer doesn't own the object, and you can't access the object using the weak pointer. You have to convert it to shared pointer first. This is an example. class person. This string name as private member. And here the main function create shared pointer of P that points to Tom, and we have an observer or weak pointer W which points to Tom also using this expression, and I'm calling function I'm passing it the weak pointer. So calling W print person, this is compilation error because W doesn't own the object. It is of type weak pointer, and to do that you have to convert it first to a shared pointer. So shared pointer P equal w.log. This is the method used to return shared pointer. Then safely you can ask print person. This is by name Tom is printed, and of course the destructor is called automatically because we are dealing with smart pointers. Summary: use smart pointers instead of raw pointers to avoid free memory manually and to avoid memory leaks. Use unique pointer if you are sure the object will have one owner in the program. Unique pointers has almost the same performance as unique pointer. Uh, so unique pointer has almost the same performance as raw pointer. Use shared pointer to share object ownership between multiple functions or threads. So shared pointers are very easy, like to use. You can share it with multiple functions, multiple threads. Uh, use weak pointer if there is a circular dependency caused by shared pointers. Uh, just remember, shared pointer has or unique pointer has slightly better performance than shared pointer. So if you are not sure there will be one owner in, of the object in the program, you can just use shared pointer. Thank you for watching.